perspective and not bake ourselves into more problems. And so I would emphasize that, mapping.
I have a little bit different. I agree with the comments, but the question is, I think that limiting the end user, okay, into one solution, because what if is wrong. The end users are very familiar with what they need to do. They're familiar with their architecture. They know when speed is of utmost importance. They can, the scheme that I showed you requires, it's a very extremely fast response, and it has to respond in that time frame. And it's not about the 25 milliseconds. That's just the processing time. It's a little bit more forgiving than that. But the key thing, I think, is that standards should be in place, tools should be in place, and we need to allow the end users to make their own decisions. That's just my opinion.
Maybe one more comment on that. I agree with everything that was said, specifically with the issue of whether latency is an issue. We've been looking at sampled value for process bus, not for synchrophaser, for a long time. We have looked at those applications. There are requirements. I do not by any means expect for synchrophaser application, whether it's C37118 or 61850-90-5, the protocols I don't think will be an issue with regards to latency for applications. You can look at them, you can get to the details of them, you got to implement them properly for the application, you know, but I don't expect this to be a determining factor. It's more the choices and design of the system. The protocols both allow for, you know, comparative with previous or present functions in the system.
Sure. Just to add as well something to the discussion, I think from an IEC perspective, the TC57 reference architecture that we are discussing, the goal is definitely that in the future all kind of legacy protocols should disappear and have just standards based on 61850 or for the application area on the SIM. But of course, to get there, we need migration scenarios, and like Ron mentioned, we need the mappings. And what I didn't mention, I have forgotten it in my presentation, we are also having currently the plan to have do a local standards for IEC mapping to DNP protocols. But there the strategy is very clear. Everything what is field communication in the future shall be 61850 based.
WISP. We've done a lot of discussions about what's going on with PMUs to substation PDCs and up to super PDCs. I'm just wondering if any work's been done using 61850 or any other protocol. Once you get to that control center PDC, there are numerous applications that got to start consuming this data. Some have requirements near real time, some don't. You know, we're going to have probably 4 or 5 at a minimum applications that all need to consume this data for one purpose or another: visualization, oscillation detection, you know, archiving. Has any work been done with these protocols inside the local area network to move this data around to various applications that need to be able to get this data?
Anyone wants to answer?
Yeah, I don't know that the communication protocols that exist are really, they're not, the use cases are not internal inside the control center to distribute that information internally in the control center. It doesn't mean it couldn't be used that way, but it's not a use case that's been identified that the formal requirements identified that would basically allow you to judge whether that's a good application for that or not. It's probably something worthwhile to look at, certainly. I think, you know, there's commercial products out there which provide that integration between the endpoint of the phaser data and where it goes and the applications that drive it. So, you know, there's commercial products that do that, whether there's going to be a separate and different protocol to do this. I don't think anybody's actually identified that, so it's possible.
Well, during the early stages, we have, and I want to make sure I understood your question, but we have actually, as you saw on the one of the slides that we were showing, the proof of concept facility, it's a full complement of a redundant, just for the purpose of having to verify. So what we have done is we've actually used one of the two control systems, if you would, as a recipient of the data, so treating it more like a data sharing sort of a system. Okay? Within our project application, we have also we do have distributed state estimation, where the application can produce data through the 61850. So there are, but again, we've done it not at the production system because we're still into the implementation stages. But there are applications that we can list.
Wants to answer the question, or any other comment? No. Okay. Any other questions?
Through the presentation, I did. Would you mind introducing yourself? Yeah, my name is Prosper Panumpavi. I am a power research engineer at the University of Illinois. My question is, through the presentation, I did understand that with the new protocol, the PMU will be able to sample measurement 120 times a second. So, in the case that we can use a different protocol, put together C27 and another protocol sampling 120 times a second, I see there will be some issue. The issue will be at the PDC level because we need to solve the power system at the same timing. If we have to solve, like, state estimation, whatever it is, we have to have the measurement at the same timing. So I see there will be some issue. We need to forecast if we have different protocol together.
Well, yeah, that's obviously a big issue at PDC. If you have multiple data streams arriving at different rates, what do you do with that? And how do you align that data? And what do you do with the missing packets from one stream versus the other? Just from a pure protocol perspective, 61850 is not dependent on the 90-5 is not dependent on a specific rate, and I don't think C37 is either. It's more of the design of the PDC and the application issue about if you've got one stream coming in at 60 and the other coming in at 120. Yep, that's. Can you really execute anything at 120, or you end up throwing half your data away on the one on that to get it synchronized at 60? It's an application issue. It's not really a protocol issue, I think.
Yeah, I agree. It's not really a protocol issue. It is application, and if again, I myself, similar to what Farnoosh mentioned, I encourage you to go to the PSTT website. About a year ago, we actually presented, and it's posted, the results of interpolation and how the PDCs, if you're bringing data in at different streams, that PDC is going to have to figure something out. So there is interpolation, extrapolation. That's going to affect your application, or it may affect your application, or it may not. So it all depends on what the application is. Again, at the distributed state estimation, and I know Sakis is sitting back there, so I thought if I mention his name, he'll look up. We have the capability to do different samples. The key thing is the application and whether or not that has an effect on the. If you want to comment on distributed, yeah, by all means, I thought maybe.
Sakis, why don't you comment, since you were called upon?
Since Vahid wake me up from the deep sleep, I guess I will have a question. Well, one of the issues that we need to address with 61850 is that if we want to be serious about advanced applications, is to transmit also the models, the mathematical models that we need. So there is payload on the structure and so on. So we need to start addressing this because right now I do not see that. Any comments?
Sounds like SIM, actually. It sounds like the SIM model is where you would do that with, yeah. I mean, for mathematical models and such, you probably wouldn't put that into 61850, but you might put that into a SIM model, where you have a more general purpose model like SIM. Just an idea. So I don't think that's being done right now, but certainly that's probably the better place for it.
Dave Bachman, Washington University. So Mark is gone, apparently. Is anyone else comfortable answering questions on the 95, the multicast over the wide area, or not?
Some questions, maybe.
Sure,
I'm certainly no Markadaniak, but I know a little bit.
I think there's, at least other than security I alluded to, there's at least three main problems. And my background is distributed computing and fault-tolerant computing and all that. How do you know that sending multiple messages, retransmitting, makes it more reliable instead of less reliable? Because you could have a lot more collisions.
You're referring to using Goose on Ethernet.
Mm-hmm.
Well, for one thing, the Ethernet architecture of 90-4 is there are no collisions. You're using full duplex switches.
But he said it was also for the wide area. I thought, maybe I misunderstood that.
Well, you could use Goose that way over a wide area network, but I think the retransmission curves are going to be radically different than what you would put into a substation. So in a substation, you're trying to do the initial state changes very, very fast. You probably are, I'm guessing you're probably going to have lower or higher retransmission curves in wide area networks with IP multicast, I would guess. I don't think that work's been done yet.
Let me maybe comment on that. I believe Mark mentioned it both for Goose and routed sample value. And you're right, it doesn't necessarily improve. It could actually increase the traffic. You still got to do your traffic engineering, make sure you don't overcrowd your network. If you're having intermittent interruptions, you're only looking at 2, 3, 4 samples. So that's, half a, maybe a few millisecond, maybe 100 millisecond. But if you have 1 second, 2 second interruption, that doesn't replace that. You need different mechanisms for that. But it's a matter of system architecture as opposed to, yeah.
Okay, that's fair. And the other thing, talked about using priorities, internet in packets. How exactly do you map priorities onto strong guarantees, delivery guarantees? I mean, they're
Actually, I'm going to need the Cisco with a C to. I don't know if anybody from there, but yeah, I think we need the other Cisco for that. I mean, guarantee. I think in IP multicast, it's not. It's quality of service, and I'm not sure there's such a thing as a guarantee on that. But that's really something I think the Cisco systems guys got to answer.
Anyone else wants to answer? I mean, from the audience, if you have an answer, please just raise your hand. Okay. Let's move on. I think we have, you want to?
I cannot answer the question, but I can tell you that we have asked from the Cisco with the C, and we have received confirmation that if you assign a priority, and I always ask, well, what does that mean? Apparently it's like from 1 to 7 or some magical number. But if you assign a priority, it's, I don't know if the word is guaranteed, but it's given a priority in terms of transmit. So that's as far as I can tell.
Okay.
I just make the comment that the priority of transmission is different than the guarantee of receipt. When you're doing the multicast, you give up something in terms of the guarantee, I believe.
I think Farnoosh mentioned this. And he used a little fancier word. He says it's your architecture. I think at the end of the day, the user needs to identify what they're trying to do with this data. If delivery of the data is of the utmost importance, And they need to figure out a way to guarantee that delivery or to make that. So it's really the burden is on the user. Earlier on, I touched on when Dan asked the question about this repeat. At some point, the end user needs to identify whether or not they need a redundant architecture. So it's just, you can continue to transmit the same packet. I mean, if the route is bad, it's bad. The data isn't going to go through. So at some point, the user needs to identify the mission critical nature of their project or their applications.
Okay, I think we have time for just one more question. Okay, last question.
Yeah, it's Tony Weeks from Manitoba Hydro. And just with the process bus applications, it seems like we're moving to more centralized control, so to speak. And I noticed Vahid was mentioning a mixture of wiring versus messaging. And should we be thinking about decentralizing control and always having wiring aspects to it, so you can't break into the controls of the system for mission critical, as he says, applications or applications where you have to be guaranteed values?
Well, the issue with process bus is it's an economic decision. If you have 5 devices and they all need the same signals, do you put, for each voltage and current, you're talking about, 6 sensors for 3 phases. So, that's 30 sensors that have to be installed, wired, configured, calibrated, tested, compared to, if you can reliably share that signal for even in a redundant system, with 2 merging units working in redundancy for critical signals. It's an economic issue. It's not really trying to centralize it, it's trying to share it. It's the processing of the data still is distributed. It's sent out to other devices. I think it's a centralized processing is another matter too. I mean, there's projects going on, where we're trying to centralize decision making on wide area control, and there's also research in how you go to agent-based systems for doing decentralized control, and there's pros and cons to both. Some of I don't know if we want to get into the details of that right now, but process bus is more, it's an economic thing about being able to share the signals. And it's really, you're not, assuming all these functions are equally critical, you're not really centralizing anything. You're simply reducing the number of interface points that have to be supported. Well, the risk is that if the merging unit fails completely, then you lose your signals, and that's why in a protection environment, it's not unusual to have redundancy in those levels too. The issue also you have to consider is whether it's any more likely for a merging unit to fail than any other component in the system too. So if you've got, if you have 5 devices and 30 interfaces, is that really more reliable than, one device that's got 6 interfaces in it? And sharing those signals over basically electronics that are constructed using the same technology. I'm not sure that and I haven't done this, but if you did a statistical analysis of the mean time between failure in those systems, I'm not so sure it comes out that putting all those sensors out there is actually more reliable or not. I don't know. Is that any work been done in that, Christoph?
There have been some papers written on reliability aspects of process bus architectures. So this is available as conference papers.
Did they conclude they're much better? What's the conclusion from those papers? And that's what we want to hear.
Yeah, I think the conclusion is, again, it depends on the architecture that you're choosing. I mean, you need to design your system so that it's reliable, and it could be shown that doing a redundant merging unit with independent communication, so basically a fully main 1, main 2 system, you can achieve the same reliability, or let's say you can achieve the required reliability.
like to emphasize that, saying this standard is better than that or this, it totally depends on how well you do it. You got to design your system. You still have to do your work. Standards they streamline things, but they don't, relieve the need to do logical, good engineering decisions. You could have triple redundancy with process bus if you like, and get the level of performance you want, as well as maybe the cost for the particular application of interest. So it's not like one is better than the other one. You can do things well, and you can do things poorly too. I have done that. A separate point I wanted to address to Tony's question. A lot of the application with synchrophasers we look at upfront here, those have a central theme to it, control center, wide area, visualization. There are many applications that are totally fine to be served with synchrophasers locally, distributed based, there's some that are already being looked at, and they're more, especially if you get to distribution as opposed to transmission system or distribution automation. You can do a lot with synchrophaser data locally. Sharing data doesn't necessarily mean centralized decision or control and analysis. You got to decide how much of data goes up, how much of it stays locally, how much of it stays right at the breaker.
Okay. Thank you. Thank you all for the great panel.
I want to, before you all pack up and leave, a couple of announcements. Again, thank you to all the speakers. Thank you to Vahid Madani and everyone at PSTT who organized this really excellent tutorial. We really appreciate it. Next, thank you to the Georgia Tech team for videotaping this. We really appreciate it, and people who care about this in the future are going to look back and thank you, even if they don't know who you are. So thanks for doing it. Okay, raise your hand if you're going to be with us tomorrow. Okay, now take that hand and put it on top of your name tag. Don't lose your name tag. You're going to be using the same name tag tomorrow, and here's an incentive. Red tickets, drinks tomorrow night at the reception. You lose your name tag, no tickets come with it when we give you a replacement. So that's your incentive to keep your name tag. Tomorrow morning, breakfast will